Okay, so we're talking about percentiles here. You've probably seen percentiles sometimes when you take a standardized test, ACT, SAT, it'll tell you, you're in the 75th percentile. You're above average, right? Or 99th percentile, whatever percentile you might get on that particular test. So it's the percentile of a distribution is the value with p percentage of observation less than or equal to. So equal to is a key factor there. So it can be less than or equal to that value. So let's go to the next slide. Okay, so here's an example. So Jenny earned a score of 86 on the test. So how did she perform, compared to the rest of the class? So we can put a percentile to that. So first you have to find 86 in the STEM plot. Remember we did STEM plots last chapter. So hopefully you see that right down here, 8 in the stem and then the 6 in the leaf there. That's the number 86. It looks like there's maybe 3 numbers above 86. There's an 89, there's a 90, and there's a 93 there. So let's count. I don't think they told us how many people were in the class. 1, 2, 25 people. So there's 25 people in the class. 3 people are worse or better than what she got. What you would do is kind of identify, okay, there are, 20 out of the 22 out of the 25 are less than or greater than. So because of that, if you do 22 divided by 25 in your calculator, you get 0.88 or 88%. And so she is in the 88th percentile. She is better or as good or better than the vast majority of people in our class. There's a few who are better. Okay, so let's try one and see if we can do this. So get out your notes here. So find the percentile for the Detroit Tigers who had 86 wins. So I'm just going to do this one. Okay, so let's try to do this. So percentile that had 86 wins. Okay, so I'm looking at this one because I want 86 equal to or less than 86. So all the numbers before that are either equal to or less than that number. So it looks like there were 30 major league teams. I'm going to count the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 that are better than 86. So this would be 20 out of 30. Get your calculator out. That's going to be 0.66 with the 6 repeating. So we have 66.6 percentile. So it would be that. And then the number of wins of Cleveland Indians is at the 90th percentile of this distribution. So interpret this value in the context. Okay, so this is weird. They gave us the 90th percentile. So let's get our calculators out. By the way, with percentiles, you typically want a whole number, so I would probably round that to the 67th percentile. Percentile. I should probably write out the word percent. I was just being lazy there when I wrote percentile. It's actually a word, I think. Okay, so the number of wins. So get your calculator out. So we're going to say 90th percentile, there were 30 major league teams, so 0.9 times 30 is 27. So now we know that we want the 27th term here, so that means there's 3 that are higher, so this would be the 27th term, so that represents the number 94. So 94 wins is how many 94 wins. Try to put the context. Always good to put a unit, in this case the number of wins. When you're answering questions, you might even answer that in a sentence. Being a little bit lazy there, but always, good idea to answer a sentence, enter in context of what you're doing. Okay. Here we go. That's a good way to say it. So 90% of teams, because of that, so they showed a little work there. The number of wins for Cleveland Indians was greater than or equal to 27 of the 30 teams. Cleveland Indians had 94 wins in the 2016 season. That is a very complete and nice answer. Again, even the other answer, there are 3 teams with 86 wins, and all of them are in the 67th percentile. That's an important note, just for you to understand, not so much for answering the question there, but just to understand that there are actually 3 teams in the same percentile. They're kind of tied for percentile, so to speak. Okay, so then there's something called a cumulative relative frequency graph. If you haven't seen one of these, they're a little different than what you're used to. So let me just show you one first, and then maybe we'll look at one and kind of identify some things. So first, what we have done is a frequency. So when we did histograms, we did a frequency chart here. So that would be like, ages. We kind of grouped the ages 40 to 44. We counted how many folks were in that group for the presidents when they were inaugurated. Only two were between 40 and 44. Can you name them? Only three were between 65 and 69. Okay, so we have the basic frequency chart here. So what you want to do is you want to kind of do the relative frequencies first. So there are 44 different first 44 anyway, presidents. So we have the 4.5%, you get all the percentages, relative means you get the percentages. And then you have to break it down cumulatively. So cumulatively is different. So you can see in the 40 to 44 age group, we have 2, but in the 45 to 45, we have 7. So this cumulative is really adding up both of those. You see it's 2 plus 7, so 9 really is between 40 and 49. And then 22 is between 40 and 54. So that huge range, all three categories added together there. So the 2 plus the 7 plus the 13 is 22. Where'd this 34 come from? That came from the 2 plus the 7 plus the 13 plus the 12. You get 34 and so forth. So you've got to cumulatively add those and then get the cumulative relative frequency. So get all the percentages of the cumulative. And so what this is going to look like, and this, again, I'm going to just show you one first. This is the cumulative relative frequency graph that just rolls off the tongue. So you can see on the x-axis is the age of inauguration, anywhere from the 40s to 70s. The cumulative relative frequency. So what this means, if you read this chart, so like 20%, 20th percentile is 50, right? So if you're 50 years old when you're president, that is in the 20th percentile. The 40th percentile would be somewhere around 53. The 60th percentile would be somewhere around 57. The 80th percentile would be somewhere around 60, 61-ish or something. And the 100th percentile, which means 100th percentile doesn't mean that there's 100% of folks that were 70 when they were inaugurated. It means that, percentile is that percent or below, or that age, in this case, that age and below. So 70 and below, 100% of the first 44 presidents were 70 or below when they were inaugurated, right? So like, let's look at what the median would be. So the median is if you could draw like 50 right there. So if you had a 50 line right there and draw it over, oh, there it is, right about there. Pretty close to it. Looks exactly 50, actually. Looks like 55. So 50, the median, in this case at 50 percentile, is the median. It's right in the middle. So the median age for the first 44 presidents when they were inaugurated was 55. The first quartile, you look up 25%. It's hard to find that exactly. You kind of go between the 20 and 40, somewhere around there. I don't know, somewhere around 51 or so would be the quartile one. 25 percentile for the first 44 presidents for age at inauguration. And then 75 would be somewhere up there, just below that dot there. So I don't know, somewhere around 60 actually, somewhere in the neighborhood of 60 is the third quartile age at inauguration for the first 44 presidents. So they'll ask you questions like, let's try one. So here is the median household income for the 50 states in a recent year. So here they are. So use the chart to answer the questions. At what percentile is California with a median household income of $57,000? I would expect California to be a higher income than a lot of states because it's a very high cost state to live in. So 57,000 is 55 is right there. So I don't know if you go straight up, it looks like, well, let's do this. Let me draw this out here. So let's go to the next slide here. Here we go. Okay, so what percentile? Okay, with 57,000. So you'd find 57 here. You draw it up as straight as you can. Draw it over. as straight as you can. I don't know, somewhere around the 79th percentile is the median household income in California. I actually thought it might be higher. Um, Estimate and interpret the first quartile of the distribution. So the first quartile is 25%. So you'd find 25% over here. You go over to the graph and go down. That looks like around 45,000. And this was, I forgot, 79 percentile, somewhere around percentile. And again, let's just look at the kind of formal answers here. I just kind of wrote very quickly. So California is about the 78th. They said, you're doing the best you could, 78th, 79th for household income. And then the 25th percentile is around with median incomes less than or equal to 45,000. Again, the concept there that's less than or equal to that amount is what that percentile means. So it means 25% of the household incomes were $45,000 or below $45,000. So that could be where that's at. I'm guessing Memphis would be somewhere in that range. I'm just going to guess, just because we're a very cheap place to live, and so maybe our median income is not as high as some other places in the country. Okay, third concept of the day is measuring position in z-scores. So a z-score tells us how many standard deviations from the mean. So our measurement here is in standard deviations. It also tells you direction. It tells you if you were better than the mean or worse than the mean, so above or below the mean. So it tells you direction by whether it's positive or negative. So if it's positive, you're better than the mean, and you're negative, you're worse than the mean. So if your z-score is. So if x, so we have this observation. We can standardize score. This is actually really helpful to do with a lot of scores. We can actually compare ACT and SAT scores using this method if you know the standard deviation of the ACT or SAT, which is sometimes hard to get. So Z is the value minus the mean, the difference, over the standard deviation divided by, so we're measuring by standard deviation, so we're dividing by standard deviations. And we just call it the Z-score. So here's a question. So Jenny earned a score of 86 on her test. The mean is 80. Remember the formula is the value minus the mean. So 86 minus the mean of 80 divided by the standard deviation of 6.07. Find and interpret her score. So you just plug it into the formula and you get 0.99. Wow, that's great. So she is in the 90, it's not 99th percentile. Oh, you got to change gears here, right? This is a z-score. So this is measured in standard deviations. It's positive, which means she is better than average. She is approximately 1 standard deviation above the mean. So greater than the class mean. So she is 0.99 standard deviations, or about 1 standard deviation greater than the class. Don't interpret just as a distance away from the mean. It's more than that. If it's positive, it's above the mean. If it's negative, it's below the mean. So it has a direction to it, always has a direction. Sometimes when students describe it, they say, oh, you're 1 standard deviation from the mean. Well, you're 1 standard deviation above or more than the mean. Let's try one. So let's get a problem here. And, okay. So the mean number of wins, so let's just kind of plug in here. So let's look at this first part here. So 2016, the mean number of wins was 81, so that's the mean. And then with a standard deviation of 10.7. So the Chicago Cubs broke the curse of the Billy Goat. That's, well, I don't know if it's a real thing, but that's something that's sports fans sometimes thought. They had this, they had a curse on there. They didn't win the World Series for a long time. But they finally won it in 2016. So they had 103 wins that year. So this, according to the formula, that would be 103 is the value minus the mean of 81 over the standard deviation of 10.7. So then you're going to get out your calculator. I like to hit Control Divide to get a fraction template. You do 103 minus 81 over 10.7. Interestingly, because it has a decimal in it, it'll automatically return a decimal answer. So 2.05, and that's positive. So positive 2.05. So find and interpret. So the Chicago Cubs in 2016, their number of wins placed them 2.05 standard deviations above the mean. So they had more than 2.05 standard deviations more wins than the mean did. The Chicago White Sox had a Z-score of negative, so this is a different team. This is the White Sox, not the Cubs. They didn't have any curse against them. Had a Z-score of negative 0.28. Find the number of wins for Chicago. So in this case, we actually know the Z-score, so we know this guy. So we're going to say negative 0.28 equals the x minus the mean. Let's see. We don't know the number of wins. Let's just call it x minus the mean of 81. That's still true there. And then divided by the standard deviation of 10.7. So to solve this, you've got to do a little bit of math. Actually, you know what? You don't have to do a little math. I forgot. This is stats class. You don't have to do math in here. Okay, so we're going to use the solve command just to solve this. If you want to do math and show off your math skills, you certainly can do that. It's not that hard. But we're going to menu 3, 1 solve. We're going to type in this equation. So negative 0.28 equals, let's do a fraction, control divide. So x minus 81 over 10.7. If you've never used the solve command, put your cursor to the right, but not outside the parentheses. Type a comma at the very bottom left of your screen. You'll see the comma on the NTI Inspire, and then type the variable you're solving for, in this case, x, and it will solve it for you. Okay, so we get x equals 78.004. Normally I round to a couple decimals there, but I'm just going to say 78. So 78 is find the number of wins for the Chicago White Sox for it. So yeah, 78, it makes sense in the context to say that as a whole number. So 78 is the mean number, find the number of wins. It's how many wins they had in the year 2016. So let's look at the formal answer here. And that's what they did as well. They said in a sentence, so the first one, the number of wins for Chicago Cubs in 2016 is 2.06 standard deviations above the Major League Baseball mean of 81 wins. Hard to say that one in context, I thought. And then the next one, again, they showed their work. And then they said the Chicago White Sox had 78 wins in the 2016 season. So it's important, again, to get in the habit of writing full sentences there. Show a little bit of work. They'd like to see that. Even though you're using the calculator, again, it's fine to just set up the equation and then write the answer. Using the calculator to solve that equation, so you don't have to show that in between step. You can set up the equation, write the answer, and that's okay to use your calculator to solve that. That's not a problem at all. That's the end of the first part of this lesson. So this is 2.1a.